Alright, first thing we're going to talk about today is percentile. You guys have seen this before. You've taken your standardized tests, and when they send them back to you, they give you this thing called the percentile. Hopefully a lot of you had really high numbers there, but what does it really mean? Now specifically, we got to get really precise. We're in statistics. Percentile is the percent of data that falls at or below. I like to think of it as who did I beat, what percentage of people did I beat or tie? Okay, that's the percentile. So if you get something back that says you're in the 85th percentile, that means you beat or tied 85% of the people. All right, do me a favor. Go into your test scores in L1, and let's say you got a 38 on that test. Figure out, write down on your paper, what was your percentile, do you think, based on this very strict definition? If you got a 38 on that test, what was your percentile? What would your percentile be if you got a 38? All right, Dalton, talk to me. What'd you do? How'd you get that? How many? 38. How many is 38 beat or tied?
5.
Nah! The score of 38. How many does 38 beat or tie? That's kind of the tricky part of this.
Is yours?
Yes, right? It's a tie. It counts if it's a tie. So the tricky part of that is it was actually 6. There was actually 6 scores. A score of 38 beat or tied 6 of the scores. So then how do I find percentile? I would then divide by the 36. So what was that, 17 or 16? About 17%. So you'd come back and it'd say you were in the 17th percentile. Okay, so percentile is the percent that you beat or tie. All right, we're going to learn a new graph. And it's called a percentile finder. I mean, it's called an ogive. I don't even know how to pronounce it. But I like to think of it as a percentile finder. It's a graph that helps you determine what the percentiles are. All right, let me just show you what one looks like. If you open up your book to page 30. I told you guys yesterday to open up to 50, didn't I? I went and re-looked at the tape. You guys were all on page 50. I couldn't figure out why, and I looked on the tape. We'll splice that out so I don't look dumb. All right, that's an ogive. That's what we're going to build, okay? You have no idea what that means, but that's what it's going to look like when we're done. All right, in order to build this ogive, I need to make a new column here, and I'll call it, I don't know, the percentile column. Your book also has another fancy word for this. Remember how this was frequency, and this was relative frequency? This column in your book sometimes is called cumulative relative frequency. Don't freak out if you see that. It just means percentile, okay? It adds up everybody you beat before, cumulative. I just like to call it percentile. All right, let's find percentile. Let's find the percent of scores that are at or below a certain spot. So how about at 24? What percent of all of these scores is at or below 24? What is it? 2.8, right? Is there only one score that was at or below 24? The 1 over 36, and there it is, 2.8? I agree. All right, now a little bit trickier. What percent of the scores are at or below 32? What percent of the scores are at or below 32?
1.
What percent of the scores? Not how many scores.
2.8.
Remember, percentile is a percentage, right?
Yeah.
So what percent of the scores are at or below? I agree, 2.8. All right, well, what percent of the scores are at or below 40?
16.7.
And how'd you get there? Is it kind of an easier way to get that?
I just went 5 plus 1.
You went that way, that's fine. 5 plus 1, he figured out there were 6. 6 divided by 36, throw that in your calculator and you get it. Is there another kind of easier way now we set this thing up like this?
The answer's already on there for 6.
Right, so what would you do?
you just copy the 16.7%.
What? Were you getting 60%? Yeah.
Sorry.
Add 2.8 and 13.
Yeah, that's what I had so far. There's this many more in here, this percentage. So could I just add those two and that would give it to me? So either way, figure out how many scores there are or take the shortcut. Okay, go ahead and fill out the rest of them. Go. What is that last one going to be equal to always? 100, right? Does that make sense? What percent of the scores were at or below 88? What percent of the scores were at or below 88? All of them, right? That's 100%. So what we're going to do is we're going to build a graph. It's called an ogive that's based on these numbers, the percentiles. And this is how we build. We draw our horizontal and vertical again. The bottom's going to be exactly the same as it was before. So we'll start at 0. We'll do our little deal here. 16, 24, 32, 40, 48, 56, 64, 72, 80, 88. Yeah.
What if there was a score that was right at 64? Like, one of the ones is, there's one score of 64, so wouldn't that change the 52.8?
Right, so what we're actually looking for here is the percentile up until 64, yeah, to be precise. All right, over here is going to be the percentile, or cumulative relative frequency. I like to call it like that too. Now, if you look at the ogives on page 30, you see they always start at the 0 percentile. So let me ask you this question. What percent of the scores are lower than 16? Think about this. What percent of those test scores were lower than 16? 0. So that's where the anchor will be, right here. And then you, we're going to go up to 100, so it goes up to 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then we're just going to put dots at these percentiles that we found. So over at 24, it's 2.8. At 32, it's also 2.8. Then at 40, the percent of the scores that are below 40, that's 16.7. Lower than 48 is 27.8. 56, lower than 56 is 36, 36. 64 is 52. 72 is 77. 80 is 97.2. 88 is 100. And it always ends up here at 100. And then you get to draw a graph for once. Just go back to first grade and play dot to dot. Just draw straight lines between the dots. Percentiles of period 3, 2009 AP Statistics, Chapter 1 test. You got you put the title on there. Please don't let me walk around tomorrow and see something like this. I don't even want to to draw it. Don't even put that in your head. You don't need to complete it, okay? It finishes up there at 100%. If you got an 88 on the test, you're the 100th percentile, so don't feel you need to finish off the graph. One of you is going to do that tomorrow. Don't do that. So third period said, somebody's third period is a great question, and I want questions like this. He said, well, this is stupid. What are you going to use this for? Well, it's actually kind of cool. Think about it. Let's say I just put this graph up for your first period, for your first test, and you know, nobody else knows, but you got a 50, and you're wondering how you did compared to the rest of the class. Can we use this to figure out how you did relative to the rest of the class? You bet. Go to 50. It's right here. Come up, cruise over, and that gives you your approximate percentile. Now I say approximate, it's not exact because I know there's 4 in here, but I don't know where they are. They might all be 41 or something, so it's approximate. It's not going to be exact, but at least it gives you an idea of what percentage of the class you beat or tied. You can also use it the other way. In other words, okay, this is the way it's been in the past. You know, what kind of a score do I need to be in, let's say, the 90th percentile? Up to 90 percentile. Go here, come down. You better be around 72. Okay. Every single AP May 15th test has had an ogive on it. They love ogives on May 15th. Okay, so know this thing backwards and forwards. All right, so what is AP statistics? Is it being able to draw an ogive? Yeah, obviously. Is it being able to use an ogive? Yeah, that's basic. But here's what AP is about. Here's what May 15th is about. Why this class is difficult. Now you have a problem like this tonight. Let's say I just gave you this, and I just gave you that, this column. And I said, okay, I want to know about center shape spread and outliers for this data. What are you going to have to do? Can I get it from that thing? Center shape spread outliers? No? Zane, what are you going to have to do?
You can use the percentiles and subtract them to find the percentage.
To go create a
histogram.
Could you create a histogram from just that? In other words, could you work backwards to this? Draw the histogram, then talk about center shape spread and outliers. That's AP. I think about how you have to know histogram backwards and forwards. You got to know ogive backwards and forwards. Then you got to know them so well you can mix and match them. You know how you would do it? You said something about subtraction. So if I knew that was 16.7 and that was 2.8, you could figure out that was 13.9. You could then figure them all out, you know, kind of a thing. You got one of those tonight. Okay, then you can talk about center shape spread and outline. Someone in the other class said, well, could I get back to this? Well, remember, these two graphs are exactly the same, right? I mean, I guess you could. I mean, if there's 11%, you know, there's 36 of them. I guess you could figure out that's 4. But what I'm saying, if you can get back to this, you can draw the picture and you can go from there. Okay. Ogive, very important graph, and you're going to see a lot of it as we go along. All right, we're going to do a little bit more work now on center. Up until now, it's been a problem. You just asked me, well, it's kind of, how do you know you're right or whatever? Now we're going to start doing some real calculations to talk about center a little bit more intelligently. The mean. Go to your formula sheets, page 3. That's the very first formula you have on your formula sheets. The top of page 3, and you see this little weird X bar thing. Can you find it? So obviously this is not a formula you have to memorize. You came in here knowing what mean was or how to calculate it, so it's not a big deal, but that's the first formula that they give us. Page 3, top. All right, first things first, this is X bar, that's how you say it, and that's going to be your new symbol for the mean. So if I say X bar in your head, oh, he's talking about the mean. How do you find the mean? Don't we add up all the numbers? That's the summation symbol, that means add them all up, and then divide by how many numbers we have. That's how we calculate the mean. Now here's where AP is sinister. They're not going to give you a bunch of numbers and say, calculate the mean for me. Here's what they do with these formulas. If I gave you the mean, and I gave you how many scores there were, could you somehow figure out what the sum of those scores would be? Could you work backwards? That's the kind of stuff they're going to ask you to do. For example, let's say, okay, the mean was 40. There was 100 students. Can you figure out the sum of all of them? Or something like that. Oh yeah, you could do that, right? Just multiply it. It must be 4,000. So that's what they're going to do with these formulas. If there's 3 unknowns, they'll give you like 2 of them and make you figure out the other. So get used to that. They'll ask you weird questions like that. The median. You guys have seen this before. It's great examples in your book. But the median, if you'll remember, is just the middle number. You put them in order first. That's key. Okay? Let's say you got 9 of them. You go find the 5th one. Isn't the 5th one right in the middle? So in one book there was some weird formula where you say, okay, how many numbers do you have? 9. Add 1 to it, 10. Cut it in half, 5. It's the 5th number. Don't worry about that formula. It's always the middle one. Now remember what happens if you have an even number and you put them in order? You have to find the middle of the 5th and 6th one. I'm seeing some nods. Okay, if you don't remember how to get median, there's examples in your book. Take a look at it. So you go between the 5th and 6th number and you find the mean of those two. That's your median. Okay, so the median is what we call the middle number. Now, is this class about you going and calculating the mean and calculating the median? No. What this class is about is can you make some observations or know some things based on the mean and median. Now, I've got some very key things here. This is huge. We say that the mean is not resistant to extreme values, but we say the median is resistant. Now, this is what I mean by that. You guys aren't into buying houses or anything like that, but every month in the Sacramento Bee, they talk about the typical home prices in Sacramento. And if you look closely, they always say the median home price. Now, the general public has no idea what median is, or how you put them in order, and n plus 1. They don't know that stuff. They have no idea what median is, but they just know it's the typical price for somebody. That's what they know. Now, wouldn't it be a whole lot easier if the paper would just say, here's the average home price? But they don't. They don't use the mean. Why? Why do they always, you look in the next time it's in Sunday edition, why do they always use the median home price if they're trying to talk about a typical amount someone's moving in is going to have to pay? What do you got?
Because then you don't have to worry about outliers.
Well, so what does that mean? I don't know.
It's like if you have one random home that's selling for like $4 million, and then all the other ones are in the $200,000 range, it's going to jack your average.
Let me show you how this works. He's exactly right. Go to your numbers. Let's add a new test score on the bottom. Oh, by the way, let me show you this real quick. I've got a new button for you to calculate the mean. You guys showed me how to do mean before, and I said I got a better number for you. Let me show you that number, that way to get that right now. So we've got our test scores in L1. So turn on your calculator and go to Stat. And we want to do a calculation here. So we move over to Calculate. You're going to learn about all of these things down the line. But right now we're just going to do a one variable statistic. So you can hit 1 or enter. All right, now at this point, if your data's in L1, you're good. If your data was in L2, L3, L4, you have to put that right here. So your calculator knows where to go look for the mean. But if it's in L1, don't worry about it. You can just hit enter right here. So hit enter. And there's that top thing is X bar. Now you know that that's the mean. Bunch of other stuff that you're going to learn about real quick. Keep going down and you see the median. So it calculates the mean and the median right there for you. Okay? Alright, let's do as we said. Let's add a new test score. So go back into your list and go down to the bottom. And I don't know, let's say somebody got a test score of, I don't know, 92,562. Alright, now let's go back into one of our stats and do some calculations. And take a look at what happened to the mean. Did the mean just lose its mind just based on one value? That one value! The mean is not resistant. It saw that number and it just started running to it. It was attracted to it. One value, one extreme value, the mean went crazy. That's why they don't give us the mean when they're talking about home prices. Because aren't there a few houses out there that are gazillions of dollars? There was a typical person moving in, reading the paper, looking for typical home prices. Should those be included? I don't think so. So that's why they do the median. Go down and look at the median. Did the median go crazy because of that big number? No, you're just a placeholder out there. You didn't change my middle. Okay? So that's why the newspaper is going to use the median. All right, so we say that the mean is not resistant to extremes. It's going to run to them. Whereas the median is resistant to the mean. All right, so what does that mean for what we're doing right now? If you have data that's symmetrical, you don't have any extreme values, right? Then the mean is going to be approximately equal to the median. All right, here was the question I was going to ask that many of you wrote down already, but here's the question. So far, period 3 and period 4 are 0 for 2 on this answer. And you guys have it written down, I think, so it's not fair. But I'm going to go to Monica? Marika. Okay. All right, let's say you have data that is, well, first of all, what is this? Is this skewed left or skewed right?
Skewed right.
Correct. Okay, so it's skewed right. So if you have data that's skewed right, what do you think the relationship is between the mean and the median? In other words, which one will be bigger, which one will be smaller? So if you have data that's skewed right, the mean is, what do you think? Is the mean going to be smaller or bigger? Think about it. It's good. You all are thinking about this, right? Nobody's blurting out answers. So this is what I was talking about. You learned about skewed left, skewed right. I said you need to know it. Come in here knowing what that means, what that picture means. Stalling for you. What do you got? You got 50-50, so throw out what you think. Don't, you think the mean will be bigger than the median? You don't sound very confident. Now, tell me what you think.
Yes.
Dang it, you got it right. That's actually right. The people were 0 for 2 earlier today. Connor Sutton and someone else said the opposite. They didn't understand what skewed right and skewed left is. I don't know if you were guessing or not. I'm not too thrilled about the confidence of your answer. But let's think about why that's right. What creates skewed right? That means there's some big numbers out there, right? I got to keep that tail going all the way to the big numbers. What are those big numbers going to do to the mean? Isn't the mean going to react to them and go out to that tail? Whereas the median's going to pretty much stay put. Skewed left, same idea. The mean is going to be less than the median in that situation. Why? Because I got some really small numbers out there. All right, let's go back to those test scores. I want to get rid of that crazy score. You might want to get rid of it too. That was just for illustration purposes. You go down to it, hit delete, the delete button. DEL. We'll get rid of it for you. All right, if we go back in now and do a one-bar stat, our mean was 59. Our median was 63. So the mean was less than the median. I don't even have to draw the picture now. If you know that the mean is less than the median, the data must be skewed. Left, right? What kind of answer is left, right? Left, correct. Left is correct. It's skewed left. Now go back to, remember our pictures, old 22 out there? Wasn't the data skewed left? We were talking about that earlier, right? That was skewed left. Now I got proof. It definitely is skewed left. Okay? You got to spend some time with this. Okay, you're in the big leagues today. Today's stuff moves ahead. Okay, so what are we talking about? You need to understand what the precise definition of the percentile, how to build an ogive, how to use an ogive, and how to go from an ogive back to a histogram. Mean and median, most important, this is the AP part. You understand the relationships between the mean and the median and the shape of the data. Yeah?
So what we learned, this is going to go into the...
Okay, so what's new today?
Center.
Definitely center. So when you're talking about center now, you're going to give me the values of the mean and the median. Okay? We've learned a new graph, trying to represent data. Okay? And if you don't have a picture, but you know these two, you also know something about shape.
So is like basically all this work kind of not validating, but like making sure all the other work is correct? Because if one works off and the other.
Well, more importantly, let's say I don't see a graph, but I just know the mean and median. You now know the shape without even having to see the graph. Okay, so it's different ways of getting at those four things. Learning different tricks. Okay.